Unit 5, Right Triangles. Preview video 5.5, Right Triangle Applications. Sit up. Ready? Take a deep breath. Hold. And exhale. We're in the final preview video for our amazing unit on right triangles. You want to keep your reference booklets handy, please. This is called your right triangle toolbox, the right triangle toolbox, because it lists the 5 different tools that we've been using for right triangles. You want to keep that very close to you at all times. We're going to do a quick recap of what we've learned so far. So if you have 2 sides and you need a 3rd side, you pythag. Have 2 sides, need a 3rd side, pythag. We have 2 sides. We need a 3rd side. So we follow along. We got a leg, leg, hypo, pythag. Circle, plug, chug. Get in the habit of doing this without a calculator. The opposite of squaring is square rooting. (3√7). Have 2 sides, need a 3rd side, pythag. Then we have 45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. When you chant it, I'm touching the legs. That means they're equal. The legs are equal in a 45, 45, 90. The hypo is whatever the leg is times root 2. So legs are equal. So if this is 9√2, guess what y is? And then we times by root 2 to get the hypo. Root 2 times root 2 is just 2. So we are going to get x equals 9. Then you have 30, 60, 90, short leg, root 3, short leg times 2. 30, 60, 90, short leg, root 3, short leg times 2. Very important to identify where the short leg is, long leg, and the hypo. Hypo is always across from the right angle. That would make this the short leg because it's across from the 30. That would make this the long leg because it's across from the larger angle. 3√3 times root 3, any radical times itself is just the number on the inside. So that becomes 3. 3 times 3, y is 9. If I do 2 times 3√3, only the outies talk to each other. 30, 60, 90, short leg root 3, short leg times 2. Then we're like, well, what happens if you don't have a 30 or a 45 or a 60? We use Sohcahtoa. Now your vocabulary is opposite, adjacent, and hypo. From the 53, we make this the opposite, this the adjacent, this the hypo. We have the opposite, we need the hypo, and you come over here, OH is so, sine of theta over 1 equals opposite over hypo. Circle, plug, chug. Theta, theta. Keep parentheses around this entire entity. Once again, this is a singular unit. It's not 53, it's the sine of 53. Cross multiply. X is not by itself yet. We get x equals 15 divided by the sine of 53. So now you're going to get the calculator. Make sure you're in degree mode. So in the large screen calculators, that's mode. Down, down, over, degree flashing, enter, clear. We are going to do 15 divided by sine 53. Enter. Round it to the second decimal place. That's going to be 18.78. 18.78. Last one, we use Sohcahtoa to find side lengths. We use inverse Sohcahtoa to find angles. So in this case, we're going to look for this angle, and we have the opposite, we have the adjacent, and we have the hypo. We have the opposite, adjacent, and hypo. We're looking for an angle theta. And you're like, well, I've got all three. Do I use inverse sine? Do I use inverse cosine? Or do I use inverse tangent? I do expect you to write all three of those down. And if you have all three, you have a choice. You can choose any one you want. That's the whole point. So, and you only have to do one. The first video, we did all three just to prove the point. Now, if you can have a choice, you can choose what you want. So I'm going to choose, just for giggles, cosine, because that's usually the one that's not chosen the most. Humans, we have a tendency to either do the very beginning or the very end. So down here, I'm going to do inverse cosine. My adjacent here is going to be 40. And my hypo is 58. And that's going to get me that angle theta. So I do second function cosine. You get inverse cosine. 40 divided by 58. Enter. Angles only, I will allow you to round to the nearest whole degree. So it's 46 degrees. And you get this angle, I know because this is 90, these two angles have to add up to 90, so you don't need to do inverse Sohcahtoa here. You just do 90 minus 46. And we get 44 degrees. Ta-da, you're done. So that is all 5 tools. Now we're going to apply those tools to practical, real-life problems. Before we do that, let's recap here. You need to understand the vocabulary of the angle of elevation and the angle of depression. The angle of elevation and the angle of depression. We're going to recap that. An angle of elevation starts at a horizontal and angles upward. It's very important. Starts at a horizontal and angles upward. That would be an angle of elevation. An angle of depression starts at a horizontal and goes downward. So if you put your arms one on top of the other, elevation, horizontal, going up, depression, horizontal, going down. It's very important that both angle of elevation and depression start at a horizontal, not a vertical. So right here, I like you to zoom through these, and I like you to mark the angle of elevation. So wherever you see an angle of elevation, I like you to mark it with an E, and an angle of depression, I like you to mark it with a D. Should only literally take you about 20 seconds. So that's what I'm going to count. 30 seconds. Ready? E for elevation, D for depression. Go. All right, in each diagram, this would be the angle of elevation. This would be the angle of depression. If you look carefully, because they both start at a horizontal, that creates parallel lines, which means you're going to have armpits of the Z going on with every angle of elevation and depression. Right here, this one would be the angle of depression, and this would be the angle of elevation. This one, the angle of elevation is right here, and you're like, wait a minute, there's no horizontal for the angle of depression. Guess what? You can draw in the horizontal, which you will need to do frequently, so your angle of depression was right here, friends. Once again, the angle of depression and elevation create alternate interior angles, in my class known as armpits of the Z. Once again, zoom through these. You got 30 seconds. Where's the angle of elevation and depression? Go. Grab your red pens. Let's check your work here. Elevation would be right here, E for elevation. Depression, again, you had to add the horizontal, it's right there. Armpits of the Z. Coming right here, your angle of elevation is here. Your angle of depression, you have to draw in the horizontal line right there. Once again, armpits of the Z. Coming down this way, your angle of elevation, right there. Your angle of depression, right there. And we have armpits of the Z. Super important, as we do these practical problems, I'm going to be very, very strict. You must follow the finger track and read out loud. It is absolutely vital. Ready? I'd like you to put your finger right there, finger on your paper. I'd like you to read aloud as we track. Follow with me. Go. A research vessel uses sonar to find an unknown object on the seafloor, 1,000 feet diagonal distance from the hull of the ship. The angle of depression from the hull of the ship to the mystery object is 27 degrees. How deep, straight down, is the object from the ocean surface? Step 2, you're going to highlight the keywords and phrases or underline. We have a vessel, and there's an unknown object, 1,000 feet, diagonal distance from the hull of the ship. Angle of depression from the hull to the object is 27 degrees. How deep? Straight down. Now, you've got 30 seconds to make a drawing, label the drawing, and list your given information. Do this now. Let's see how you did. First off, we have ocean of some sort. We have a research vessel. And we have the ocean floor. We have a mystery object that is 1,000 feet diagonal. Keyword there, check your work. So this, my friends, is the 1,000 feet. Cross stuff out as you deal with it. Angle of depression, that's going to be at a horizontal going downward. So that angle of depression is 27 degrees. And we're being asked to find straight down the depth. And like altitude, when you're dealing with airplanes, depth in the ocean is always a straight down from the surface. It makes a right angle. There is our unknown. Now we're back to have, need, do. From the 27, that would make this the opposite and this the hypo. So we have the hypo, we need the opposite. Oh, so. So you cross multiply. X equals sine of 27 times 1,000. Calculator looks like this. Okay, so I'm going to do sine of 27 equals times 1,000 equals. Do that in 2 steps. That's 453 and 99. So if we round up, at this point we'll call it at 454. So our depth here of the object is 454, and watch your units, feet. Now you're going to do a couple problems on your own. Finger track, read out loud, read the problem, And then you draw the problem, work it through. Read the problem, draw the problem, work it through. Do this on your own. When we come back, I'll do the explanation, but I'm going to go really fast. I expect you to be correcting in red pen and not copying. Really try to do this on your own. At some point, you got to take those training wheels off and see what your own brain can do. Do this on your own, these two problems, then grab your red pen and correct your work. I'll be looking for corrections. Pause the video. All right, welcome back. That should have taken you start to finish about 5 to 7 minutes for both problems. Now we're going to correct. So this object is called a clinometer. You're going to be using one next week. It's used to measure depths of angles. So your storyline should look something like this. Says Tom is standing 400 feet away from the tree. So 400 feet, there's Tom. Here is the 400 feet. Boom. He uses a kilometer to measure the angle of elevation from his eye level. That's kind of an important notation. High level. And the angle of elevation from his eye level is going to be 38 degrees. Watch out for this. What I'm about to do might be an issue of extra credit next week. Pay attention. Tom is 5 feet 4 inches tall. So his entire height is 5 feet 4 inches. But his eye height right here is 5 feet off the ground. And we're being asked, how tall is the tree? So our ultimate ambition is to find the entire height of the tree. So I'm just going to write tree question mark. But you should note that there is a right triangle embedded in here like this, right here, and you're going to have to find this little piece. We're going to call it X. I'm going to bring this down so you can see it. You're checking. It's not exactly straight, X. And if this is 400, this is 400. And we have 38 degrees. Have, need, do. You should have done that. Have. We have the adjacent side. This would be the adjacent side. You need the opposite. This would be the opposite, of course. Therefore, you do. OA is tangent. Theta over 1 equals opposite over adjacent. Pay very close attention, friends. There's a extra credit at stake. Pay close attention. The tangent of 38 degrees over 1 equals our opposite, which is our x, over our adjacent, which is 400. Cross multiply. Our x is going to equal tan 38 times 400. Your x is by itself. Tan 48, tan 38 times 100. So right here, friends, you should have done tan 38. So tan 38, enter, times 400, enter, and we get 312.51. That is not the height of the tree. Careful. 312.51 feet. We come up here. What you just found was this, 312.51. That's not the total height because it stops short 5 feet because Tom's measuring from his eyeballs 5 feet off the ground. So the total tree height is going to be 312.51 plus an additional 5 feet. So the total tree height here is 517.51 feet. Very few students get that right to start with. I want to see your corrections. If you did, put a giant star smiley. Woohoo! I'm amazing. If you got it wrong, totally fine. Write yourself a note. This one I'll do with you. It says an airplane is flying at 5,000 meters altitude. The plane is 72,000 meters diagonally from the landing strip. At this moment, what is the angle of depression? So we have it's flying 5,000 in altitude. The plane is 72,000 meters diagonally. And we're being asked, what is the angle of descent or depression? So we establish ground here. We have an airplane. Airplane's flying at 5,000 meters in altitude. That's a straight down concept. Diagonal 72,000 to the end of the landing strip. What is the angle of descent or depression? And that's going to be horizontal going down, which means your theta is here. But you can carry over that 5,000 to this side because the angle of elevation and depression make an armpits of the Z. Have, need, do. From that angle, this would be the opposite, this would be the hypo. So you should have done inverse sine 5,000 over 72,000, and that would have given you your angle of descent. So second function sine 5,000 divided by 72,000. We're going to round to the nearest whole degree. You should have gotten 4 degrees. Or you get 4 degrees. Last problem, pause the video, do this one on your own, and then restart and check. Pause the video. Welcome back. Students, super important that you're actually pausing the video and trying this on your own and not just copying. It says we have a wheelchair ramp that covers 3 6-inch high steps. So each of these steps right here are 6 inches. And it says the length of the ramp is 4 feet. We want to find the angle of elevation of the ramp. There is a right angle here, so we're being asked to find this angle of elevation of the ramp, round to the nearest whole degree. So let me bring down this information here. This is 6 inches, 6 inches, 6 inches, which means it's 18 inches. Your theta that you're trying to find is right there. This is 4 feet. All right, super important here. There is a discrepancy in units that you needed to account for. This is inches, this is feet. Everything has to be in the same unit. So either the inches go into feet, which if you did that, that's 1.5 feet, or the feet goes into inches, which is if you did that, 4 times 12 is 48 inches. I'm going to use inches. I have the opposite, that'd be the 18, and I have the hypo, and I need the theta. Inverse sine, opposite over hypo is going to give us that angle theta. Inverse sine, if I do inches, that's 18 inches over 48 inches. Gives you theta. If you did feet, it'd be inverse sine, and that'd be 1.5 feet over 4 feet. Either is going to get you the correct answer. Let's do both. First one, second function sine, that's going to be 18 inches divided by 48 inches. And we get 22 degrees, or inverse sine, and it's 1.5 divided by 4, 22 degrees. Both work.